All right, guys, how's everyone doing? First day. All right. Before we get started, I just want to introduce like who we are, so you guys like know why we're here. My name's Ronit. I'm a senior in high school. I go to Novi High School, if anyone knows where that is. And I was the founder of NHEX, which we'll explain later.
Hey guys, my name is Max, and I'm a co-founder of NHEX, and I'm also a senior in Novi High School.
Hey guys, my name's Ashley David. I'm an NHAX organizer. I'm a junior, and I also go to Novi High School.
Hey guys, I'm Advai. I'm a junior, and I also go to Nova High School.
Hey guys, I'm Dhruv. I'm an organizer for NHEX, and I go to Northville High School as a junior.
Hello everyone, I'm Jason Israelov. I go to West Bloomfield High School and I'm one of the organizers.
So have any of you heard of what a hackathon is? Has anyone been to a hackathon? Oh, yo, have you been to NHEX before? Oh, that's pretty dope. Okay, so for those of you who don't know what hackathons are, typically hackathons are like a 24-hour to 48-hour event that lasts for about 2 to 3 days overnight. And it involves people coming together to solve a problem. And that can be like, I've seen things from people making pancake batters, or people making 3D printers out of pancake batter, to like people making robots to solve global warming. So the issues that people try to solve are, you know, they span a lot of areas. But essentially the main idea is that a bunch of people will come together. They'll form groups, usually up to 4. And then these groups will address a problem using coding. And that can be through building a website. It can be through building an app, robots. We've seen VR hacks, pretty much anything they can dream of. And hackathons are pretty common in college. I'd say about every major college has a hackathon, whether it be MHEX at the University of Michigan, PennEps at the University of Pennsylvania, Harvard hacks, Princeton hacks, Tree hacks at Stanford. Every college has a hackathon. And we also see a bunch of hackathons at the corporate level as well. I don't know how many of you are currently working, but I almost guarantee you that if your company is related to the technology sector, that they have a hackathon. And me and Max actually went to MHAX a couple years ago. It was our first experience at any hackathon ever. And we were just shocked because as a high schooler to walk in, and I remember walking and seeing just like a row of sponsors, whether it be Google or Apple, and we were just dumbfounded because we had never seen anything like this before. And then after we came back from that event, we thought like, this is amazing. You know, we want to go to more of this stuff. And we searched for more in Michigan because, you know, traveling is hard. So we searched for more like near us, and there was just nothing. There was literally no events besides MHEX. So we did the next best thing, which was start our own. And we began as Michigan's first high school hackathon about 2 years ago. And, you know, our first year we got about 100 people. We had like a few sponsors, and it wasn't that great. But the next year, which was last year, we reached over 20 different schools, 300 attendees. We had sponsors such as Domino's, Microsoft, the University of Michigan. And actually, we're hosting another event this year that I'm going to let Max tell you a little bit more about.
All right, hey guys, my name is Max, as I mentioned, and I'm also a co-founder of NX. And this year, our third annual event, it will be on Saturday of May 19th, 2018. And we have much more sponsors than we have ever had, such as Microsoft, Linode, and University of Michigan.
But the real topic of our presentation isn't hackathons. It's supposed to be why STEM education is flawed. And that's kind of a reason hackathons, you know, came about. And so let's take a deeper dive into Michigan classrooms and how they approach STEM subjects.
So the most common way that most schools approach teaching STEM subjects and computer science is what's called as learning through memorization. So this has been the most commonly used strategy, and although that it is the most commonly used, it's actually not the most optimal because much research has shown that memorization actually inhibits real learning from occurring. And many people around the world and around the country have noticed that when they're forced to memorize certain subjects, like let's say you're learning computer science, and everything you learn is all memorization, all definitions. Well, the fact is that that can really inhibit real learning, and in the end, it'll make you not passionate about the subject that you want to be in. So the other kind of way that you can learn in schools is what's known as learning by doing, or what's called as project-based learning. So I guess something else about memorization is the fact that many studies have shown that students who learn only through memorization have actually not been able to understand and experience these concepts. But when they learn by doing, they actually learn more deeply, they experience them more deeply, and they score better on tests, which I know that is actually one of the main goals of schools. Now, just to illustrate how important and how much better learning by doing is, we have a quick demonstration.
So basically what we're going to do is we're going to teach you guys 3 definitions or 3 key terms that you're going to need when you're programming on Python, which is actually a coding language. So we're going to teach you 3 definitions. So the first one is actually that I'm going to talk about is what a variable is. So there are many different variables that you can use to store data in your code, but the 3 that I'm going to talk about today is a string, a double, and an integer. So just starting off with an integer, everyone knows what that is, right? It's just a whole number. And so when you want to code this, you put int, and then you put whatever number you want to code, and then that stores that number to whatever number that you attached it to. So it's essentially storing that number into that variable, which is called an int. And so you can do the same thing with another type of variable, which is called a double. So it's almost the exact same thing, except when you go with ints, you can only use whole numbers. However, when you use doubles, you can actually use decimals. So the last type of variable there is a string, and this is for when you want to store words or phrases into your code. So this could be, the way you'll know that it's a string is because it'll have quotation marks at the beginning and the end of it, and when you actually code it, it'll show up in green. So this is how you're going to know it's a string. So now that you have these 3 different variables, how do you actually use it, right? Like there's no point if you can only use it on the computer. So the way that you kind of bring your code to life is actually through the print statement. This is a really important thing because it's what connects your code to your actual output screen. And so by using the print statement, you'll put print and then whatever your variable was. So say, for example, I wanted to print out the number 503. So then maybe I put frog force. That's going to be my string name. And then I set that equal to, in quotation marks, 503. So it'll be stored as a string, right? And then in the end, I'll say as my print statement, print frog force. And what it'll print out, does anyone know? Is anyone paying attention? 503, yes. So just like that, I'm able to bring my code to life. And this is why it's actually super important. The last type of coding definition I want to talk about today is the if statement. So this is actually really cool, and one way that I learned it that I think was really beneficial was actually applying it to real life. So I know we're all in high school, most of us, and we all get report cards, right? Yes? So maybe when we get report cards, and when we were younger, we had to deal with our parents. If we got all A's, we'll get $1. If we got all B pluses, we get 25 cents. If we got all C's, you get nothing, right? So just like that, you might not even know it, but you're actually coding, because if you put this into your actual Python screen, you'll actually be able to code this, and you'll be able to assign it to different numerical values through the variables that I was talking about previously, and you'll actually be able to have a whole coding program. So now Drew will talk about this.
We want you guys to just take a minute and just memorize these definitions. Just take a minute, memorize these word for word. Just have it ingrained in your brain, because we're going to have a little quiz after. Just completely memorize it. We're going to count for a minute.
Does anyone think they're going to get 100? How about 50%? Anyone?
Does anyone know how to code? Try it. Okay. This experiment will work better if you don't know how to code. 15 seconds. Okay, and time. Do not memorize this any further. Have a short little quiz to test if you understood what you memorized. I know we don't have computers for everyone in the audience, but if you have a piece of paper or something, you can try to jot this down. And let's see how many of you can actually do this. Confused? Anybody 100% sure that they got it? Okay, who is confused? Raise your hand if you're totally confused.
It's okay, don't be shy.
Yeah, don't be shy. The purpose is that you're supposed to be confused. It's good to be confused. So wait, can you guys raise your hand again? All right, can you come up? All right. The purpose of this experiment was to kind of show that by forcing you guys to memorize something, you won't really learn anything. Fortunately, we also have Drew here who's going to walk you through a project so we can demonstrate how learning by doing will actually make all you confused people unconfused. So why don't you come over here? Can you hook that up? All right, Matt, introduce yourself.
I'm Matt.
All right, Matt.
Say it again in the mic.
I'm from 578 Fairport, New York.
How old are you, Matt?
I'm 17.
17. Okay. Any shout outs you want to give? Okay, no. Not even to your team? To your team?
Oh yeah, I hope we do well.
Okay, okay.
All right, so over here we have something called the Python shell. This is our idle. So this is where we can type commands, we can declare our variables, we can do all of that. So we're just gonna make a new file right now, and we're just gonna save it as project. So this is where we type all our code, right? So as Ashley was saying, in Python you have variables. Variables are denoted by names, and you can assign data to them. So there's 3 different types of variables we'll learn today: integer, I can't type, string, and float. So to declare an integer, let's say we want to do age. Let's just give a profile of Ashley right now. So the age of Ashley, what's your age? Or no,
Yes, 17.
17, all right. And name, what's your name?
Matt.
Matt. So we're gonna make this a string because strings hold words or phrases. So we'll put Matt in there. And then let's just say your team underscore number. Another thing about variables is that it can only be one phrase. It can't be multiple words. So what's your team number?
578.
578, all right. And let's put a decimal in there. What can we do as a decimal? What's your grade in AP, or what's your grade in math right now?
Like
Percentage.
like 85.
5 point, let's do 85.1 just for demonstration purposes. So we have Matt, he's 17, he's on team number 578, and his grade in math is currently 85.1. If we save this and we run this project, nothing will happen. That's because we're not printing anything out back into our idle. So if we go ahead and we just do print, the way print works is you do print and then two parentheses, and then inside you put your variable name, right? So we'll just print his age, we'll print his name, we'll print team number, and we'll print his grade in math. Now, if we run this program, we'll see everything outputs into our idle screen. So that's how variables work, that's how print statements work. Next, we're gonna learn how operations work. So we can do all the basic operations in Python. That includes addition, subtraction, multiplication, and division. So let's just have a variable a, and we'll make that 8. And we'll have a variable b, we'll make that 2. So in order to do addition, we can just do print, like we learned before. And we can take our 2 variables, our a and our b, and we can just add them together. A plus b. Pretty simple, right? We run that, and we get 10. Same thing goes for subtraction, multiplication, and division. Now, one other operation that Python can do is something called modulus division. This gives you the remainder of quotients. So let's say I have 9 and 2, and I want to find the remainder when I do 9 divided by 2. So I can do a modulus is represented by percentage, and we do b. And if we run this, then we get 1, because we all know 9 divided by 2, you take the remainder of that, you get 1. So that goes over all the operations: addition, multiplication, subtraction, mod, and division. Now lastly, the more like advanced concept in Python is if statements. So the way if statements work is you have if, and then you have 2 parentheses, and inside your parentheses you're going to put a condition, right? Then you're going to put a colon. You're going to type some statements here. Now, if this condition is true, then these statements will execute. And then you can also just do like an else. So say this condition is not true, then these statements will run. Does that make sense to you? Okay. So let's just do a condition. Let's say if, so we'll have like a variable grade is equal to 90.0. And then if we do grade is greater than 85, then the statement we'll run is print, and we can say good job. So if 90 is greater than 85 in the idle screen, it should print out good job. And else we'll just print out try harder.
So what will we print out? If he ran it right now, what would we print out? Anyone? Yeah.
If I run it, good job, there we go. And then another thing for when you're doing these conditions, say you want to just do like an equal sign, you can't just do equal, you would have to do equal equal. That's just how Python works. You need double equal for conditions. So let's just say if grade is equal to 90.0, and we ran that, good job. So I think that's about it for the basics of Python. Now we're going to try giving you a program to run, and we'll see if you can do it. So, what should...
So you guys should try it on your own phones, so that way you guys can also be playing along. So Matt's going to do it on the computer, but if you guys think that he's doing something wrong or you guys have a better idea, do it on your phone, and then we'll call up people so they can fix his code.
And we're going to show the exact same quiz. Hopefully, actually, I'm going to get a gauge. How many of you feel better now that Drew taught it to you and did like a mini project before you just memorized it? Good amount of people? That's good. Well, let's see how much you actually learned. All right, Matt, you want to get this a spin?
So the first prompt is create a string named dog that holds the value Clifford. Print out the string. So what are you thinking right now before you start?
Oh, I'm thinking that I need to have, what's it called?
A variable?
Yep. So, like, dog, and then print Clifford. I'm not sure.
Okay, and so let me help you out here. So we have the variable dog right here.
Okay.
And what we want to do is we want to assign it to the word Clifford, right?
Okay.
And in Python, how you assign something is you do equal sign. Okay, and then you're going to do a quotes and write whatever you want in the quotes. So right now, what Matt has on the screen is he has a variable dog assigned to the word Clifford. And what he's going to do after that is print the variable dog, so it prints Clifford, whatever's being held in the variable dog. Is that what anyone else got? Yes? I see a lot of thumbs up, heads nodding. Good job. Okay, awesome. Does someone else want to come up for the next challenge?
All right.
Yes? I see a hand up over there.
Thank
Thank you very much, Matt. Could we get a round of applause for Matt?
Huge round for Matt.
Hello, I'm Jason. What's your name?
I'm Justin.
Come over here in front of the crowd. Tell us about yourself, Justin.
Oh. I'm Justin. I'm from Richmond, Virginia. I'm team 422.
How old are you?
I'm 16.
Awesome. Okay. Yes. He said yes to programming
Can we
before.
get someone who hasn't?
Well, that's no fun, though.
A brave.
A brave soul that wants to try it out,
That girl
who
coming out?
doesn't have any experience. Feel free to try it. We'll help you out. Sorry about that, Matt. Matt, we'll give you some harder challenges after if you'd like.
I don't know how to do this one, so like.
Totally fine. We'll guide you through it.
What's your name?
Abby, hi.
Abby, introduce yourself, please.
Hi, I'm Abby from Team 3637. Hi.
Oh, awesome. How old are you, Abby?
I'm 18.
18. Okay, awesome. And what state are you from?
I'm from New Jersey.
Is anyone else here from New Jersey? All right, so your second prompt is write a program that decides whether the number 7 is even. Print the result. Any thoughts right now?
Okay. I'm thinking you have to make a variable. That number is 7, right? Okay.
Okay.
Should I delete this?
Yep. Just go ahead and delete that.
Number equals, okay, space.
So,
So right now what you're doing is you put number equal to 7, and when it's in quotes,
what happened?
another tip for you guys, what do you think happens if it's in quotes?
Yes.
It's treated as a string. Sorry, yeah, someone called it out over here. It is treated as a string. So what I want you to do is do not put it in quotes, so that way it knows it's an integer.
Okay.
Okay?
Thanks.
Awesome. So now what do you have? You have the variable number assigned to what?
Say that again.
You have the variable number assigned to the number 7, right?
Yeah, it's 7.
Okay, awesome. So now what we want to do is create something that would decide whether the number 7 is even or not. So do you know any type of condition that we could use for that?
Probably an if statement.
An if statement. Does anyone else agree? Anybody disagree? No? Okay, all right, awesome.
How do I write this? So you have to say like if, and then lowercase f, and then quotes or equals? Quotes. Okay. If number equals
Yep.
7. Thanks. I heard a nice. Equals 7, and then you have to put under here. What?
2 equal signs?
I have 3.
Yeah, sorry, it's a little hard.
7. Colon after the parentheses? Ah, okay, and then? No. Oh. So then condition is in quotes? Or in, just write it. Wow. Okay, odd.
So we want to print the word.
Oh, okay, print, so print is in, print? No, that's bad, my bad. Print odd? What am I doing? Can you help me?
Yeah, we can help you out.
So right now you have odd inside a print statement, but that's going to try to look for a variable called odd, which is not declared. So what we're going to want to do is do what you were doing and write print, then an open parentheses, then we're just going to do quotes, odd, end quotes, end parentheses. Now what that will do is if number is equal to 7, if that condition is true, this statement will run. Now let's say the computer is not working or something, and for some reason number is not equal to 7. So we'll do else, right? And then after the else we put a colon, perfect, enter, and then, right. Now you're just, nope, you got it. So you save that and you run it, and odd.
There we go.
Does anyone know a better way we could do this? Anything that we taught? Yeah? You want to come up?
Another girl.
What's your name?
My name is Bridget.
What school are you from?
I'm from Visitation in Minnesota.
Great. So you haven't coded before?
Not like actual code. I've done like our code thing.
Yep. Okay. So did Drew teach you any of the operations, let's say, that could help you decide whether 7 is odd or even?
Well, I was thinking that we could do. I was thinking we could do number divided by 2, but use the modulation thing to see if we had a remainder of 1 or 0. And then if it was 0, we'd print even. If it was not 0, we'd print odd.
Anyone agree with that? Is she on the right track? Okay, it's probably yes. You want to try that?
Sure. How do you do the modulation?
It's the percent sign.
Oh, it's the percent sign. I don't know where it goes. It goes after number. Oh, so now I'm trying to do if number percent, which is the thing, the modulus divide equals 0, I want to print even. And if or else, I want to print odd.
Who thinks it's gonna work?
Does anyone think it's going to work? Hands up. Awesome. So we have a lot of people raising their hands. I'm just going to explain this really quickly. So modulus, as Drew explained, is it does a remainder. So the variable number is assigned to the number 7. And if 7 modulus 2 is equal to 0, that means the number is even. So what Bridget did was she determined that if it's even, then they're going to print the word even, else they're going to print the word odd. Are there any questions about this?
Bridget, do you think you could have done this before Drew walked you through everything? If you just knew the memorization, do you think you could have done this?
No, because I didn't know where to put the number sign. I didn't know what the modulus division sign was. I didn't know that equal is equals, and or how to write the variable name, or that else's need colons, or that you need parentheses, or that you need quotation marks.
For anyone that doesn't know how to code, do you think you could have done it simply based on the term, just by memorizing it? Anyone? That's good. Everyone give a huge round for Bridget. Thank you so much. Obviously, this experiment was an exaggeration, kind of. But the harsh reality of classrooms, especially related to STEM in Michigan, is that this is not too far off from what they are. And I know it seems like we're just a bunch of high schoolers and we don't know what we're talking about, but we've actually seen, high schools from across Michigan come to NHACS, and they all tell us the same thing, is that STEM education is not being taught correctly. And I want to, does anyone here think that their STEM education at their school is absolutely perfect? I mean, well, that's cheating, but okay.
Not all of us have those opportunities.
Yeah. But the point is that STEM education is flawed. I think you all know that based on your guys' responses. We definitely know that based on NHACS and what we've seen. And this demonstration/experiment was just like to give you guys a little representation of how teachers approach STEM education. Because normally, that's how other subjects are approached. Like for history or something, you can tell someone hey, memorize these events, memorize what happened, we'll test you on this, and people will go on their way, yada, yada. For STEM education, that doesn't work like that. Because obviously people like Bridget, people like Matt, they're not gonna know what to do if they're forced to memorize definitions. You really need to go, walk them through stuff, build projects, collaborate. The audience feedback was great. Everyone was motivated. And that's kind of the way that teachers should approach STEM education. And obviously, by founding NHACS, that was kind of our goal. Because we thought that, STEM education should have a little bit of freedom. We shouldn't be forced to memorize stuff. We should be shown that you can make stuff out of it. And that's kind of where we see things. I think we have more. We have a little video. There, can you play it?
and then the teacher puts this on the projector, this little monstrosity here, how many of you might feel intimidated? Yeah, because it's terrifying. I've been coding for 10 years. I still find this terrifying. And just so you know, a lot of this isn't pertinent information. Many of these things these students won't learn for a few months. My colleagues in computer science, some of them still don't know what that word means, and it hasn't affected their job performance. Why are we doing this? We need more engineers, and yet we're pushing these kids out and trying to make this seem like it's an elite club for only the smartest people in the country. Computer science is not about numbers or random symbols. It's not even really about code. It's about problem solving and making really, really cool things. That's what I mean when I say that it's a medium. So I've put together a focus on that medium in education that I think will work better than the way we're currently teaching computer science. So the first part of my philosophy is project-based learning. Computer science is the only subject where on day one you can walk into class and in 45 minutes you can program a video game. No other class can do that. So why wouldn't you do that? Right? That's something that everyone is going to enjoy. But the great thing about using project-based learning is that, again, computer science is not about coding, it's about problem solving, and I'll give you an example of what I mean. Let's say a student actually wants to build a video game like Mario, where a little guy runs across the screen and jumps up on platforms and sort of jumps on bad guys. The first thing that you have to figure out is the steps that make that possible. How do I make this person jump? When they reach the top, how do I make them come back down? What if something bumps into them along the way? These are all considerations that you have to think about. You don't code them first, you think about them first. Then you think, what are the worst case scenarios? Like, what's a scenario that I haven't thought about yet? How do I test the solution to make sure that it works? That's all problem-solving skills that apply far beyond computer science. And when you do project-based learning, you can do that in your classroom. Another great thing about project-based learning is that computer science doesn't exist in a vacuum. You can't do computer science for the sake of doing computer science. You have to apply it to another field. That's why it was made. So when a student says, well, I don't really think I'm interested in that, that doesn't really matter. What are you interested in? And let's apply computer science to it.
And that was just a little video on some of the things we kind of reinforce, which was project-based learning. And we also want to get some feedback from you guys. So are there any teachers here, any educators? You, sir, you raised your hand. We'll get to everybody for sure. Do you mind coming up and sharing a little bit? All right, give a big hand for him. What is your name, sir?
My name is Omar.
Omar, what school do you go, or what school do you teach at?
I teach at a middle school in Long Island, New York.
And what do you teach?
We just call it Introduction to Technology. So it's 7th and 8th grade project-based learning.
And so it sounds like you've already implemented this stuff.
Yeah, so we try to, as far as the memorization, so we try not to do too much of that in the class, although you do need a certain amount of that. But we apply what we're learning, as soon as possible.
And have you seen any benefits from this project-based learning that you want to share or that you're really proud of?
As far as the project-based learning, I mean, what's really cool is how the kids invent, right, innovate, right? So I might think of something differently. I'll give them something, they take that information, and they completely make something else that, you're not really thinking of.
And all you guys know it, since you guys are all in robotics, that's an excellent way to channel creativity. And do you think that project-based learning happens at a majority of schools around the country? Or is your school kind of one of the only ones that are taking the charge on it?
I would say that schools kind of reverted back, right? But now this STEM movement is pushing a lot of that project-based learning. So, this first program, you guys, students participating in this, has definitely boosted that in a lot of different school districts. So, you guys keep showing up, we keep showing up, and we'll keep teaching it.
Thank you so much. Can we get another big hand? There was more people that raised their hands. Yes, can you come up? Can you
Hello,
introduce yourself?
I'm Greg Gilligan. I used to teach in Detroit in public schools, and I'm on the school board now. You made the example with history, and when you're teaching, you teach at different levels of understanding. Little kids can't really do major analysis. You can start showing them it, but it takes a while. When you get into high school, you need to start analyzing things, figuring out how they go together, and that gives you project-based learning. And like the example you used, history, well, and for the kids in Detroit, what does Christopher Columbus discovered the New World in 1492? They can give you all sorts of facts about that. But if you ask them a question that requires them to analyze, they have to go up several higher levels of understanding. So if you ask them, what would happen if Christopher Columbus didn't discover the New World in 1492? What would happen to the African American experience? Now all of a sudden they have to take these facts and start to analyze them. Anytime you're talking about project-based learning, you're getting them to think at these higher levels. And when you get into college, you better be operating at the top levels or you're not going to pass. And, so any good teacher, whatever the subject, should be doing this at different levels. Project-based learning forces some of them to go up to a higher level quicker.
Greg, do you have any recommendations on how schools should implement this?
Maybe one of the other teachers, I'm trying to think of who the guy is that had the different levels of understanding. And basically, you just start implementing it, having them go up there. And like I said, there's like 6, 7 levels. And if you're only going to do about the third level, don't even bother going to college. You're going to flunk out. Because a good college is going to require that you think at these higher levels, and you better start learning how to do that.
All right, thank you, Greg. Are there any more educators, teachers, faculty? Yes, can you come on up? I'll get to you, and I'll have not forgot about you. Save the best for last, right?
Hi, I'm Dan, from Team 4786. So what do you...
Okay.
what I do, or...
Yeah, can you introduce yourself?
So I teach middle school. Our middle school is a little different. We're a K through 8 district, so our middle school building is 4th grade to 8th grade. And then they eventually get into the high school. But I see 9-year-old kids, and I see 14-year-old kids, and I try to get them to think at a young age. So 4th graders, let's play with some Legos. Let's draw some things on a piece of paper, which for the high school kids, that'd be like, you're making a CAD. So just sketch something out. Can you make what you sketched? 4th graders like to build little houses. They like to make their squares, like to put their triangle tops on. And I go to, and I let them draw it out, and then when they're in the making part, I'm like, well, how do you make a triangle top out of Legos? And they're like, I don't know. And it's just to get their mind thinking, what I put on paper, can I make it? Same goes with building a robot. What you put on paper, that CAD that you made, does it apply? We use a design process, very simple. If you understand this at 9 years old, you'll be extremely successful. We think of solutions. We make those solutions. We improve on those solutions. It works. It's what they do down the street at GM. It's what they do down the street at Ford. The things that they make, they don't always work. So if you're doing electric cars, batteries, we have been trying to make batteries for the last 20 years. We still haven't had a solution. They're making them, they're improving them continuously. It's just a cycle. 8th grade, we make cardboard boats. Our kids have to make boats that they have to get 2 kids in there. They go from one end of our pool to the other end of our pool. They can make 3, 4, 5 different test models before they actually make their big boat that they go in. And it's them learning. I've stopped lecturing to kids. I just give them the basics of what they need, and then they go in our lab and they produce stuff. Because that's how kids learn. Yeah. This cardboard and duct tape. So I got the idea from MIT. So MIT does it, and I'm like, why can't our 8th graders do it? They're just as smart.
Do you have any tips to other teachers or other educators out there on maybe how they can implement? I know you teach middle school, but maybe as, you know, in high school? Yeah.
Just don't talk as much, let your kids do it. Kids are smart. There's 8th graders that are smarter than me. Like, they are. They come up with ideas that I never thought of. Where I'm like, that's interesting. We do popsicle bridges. They have to hold 50 pounds of weight. The way that they structure them, I'm like, oh, I never thought of that. And they work. And then I take their ideas and then I apply them to the next group. And then the cycle keeps going, and they keep improving, and they keep innovation. It's just the key to success.
Dan, thank you so much. Can we give a huge hand for Dan? And you, sir, can you come up? All right. Can you introduce yourself too?
Hello, my name is Bill Brokaw, and I teach at Hunterdon Central Regional High School in New Jersey. I'm with Team 3637, and I'm a former aerospace engineer. I worked for Lockheed Martin for 33 years, excuse me, and then I decided that I wanted to give back and teach and inspire high school students to become engineers. My classes are all project-based. I have no tests or quizzes in my classes. Everything is project-based. And the important thing on a project-based is not only the subject that you're trying to teach, but you want to encompass everything and show the real-world applications to what that project could evolve into. My students, you know, their projects get graded like an English teacher. Because they have to document their work. And they're looking at me like, what, this isn't English class. In the real world, you've got to write a sentence, and it's got to be clear. A good engineer documents their work very well. So it's not only the project that you are teaching, it's also how math, how English, how history comes into the whole project.
And as an aerospace engineer, can you give us some insight as to if a school that only taught memorization, how, you know, their students would, you know, would they be able to succeed at a company like Lockheed Martin, or, you know, in the corporate world if all they knew was how to spit out facts?
So you can't memorize innovation. You can't memorize all of the science behind. Go to school to learn how to learn. And when you get out into the corporate world, working as an engineer, you don't have the answer. You have to come up with the answer on your own. And it is basically the skills that you learn in school, your research skills, your questioning skills, your inquiry, your enthusiasm to solve that problem that makes you a successful engineer.
Thank you so much. I love that you can't memorize innovation. I mean, you can't say it any better. Before we go, are there any students maybe that want to speak out on this? Yeah, sure. Can you come on up? That's fine. All right, again, can you introduce yourself?
Okay, I'm Erin. I go to Iowa State University. I graduate in like a week and a half, and so I'm pretty excited about that. But I'm graduating in industrial engineering, and it's because I participated in first in high school that I'm an engineer. Just kind of two comments. My freshman year of high school, so like I'm really old now, I took, it was called Pro-E, so it was the oldest version of Creo, and it was a make a thing on a computer TBD on if we'll actually get to make it or not. So I decided as a freshman in college I was going to make a skull, and it didn't work. And so I'm like, well, that was dumb. And I decided that I wasn't going to be an engineer. And so then I joined first and did some robot stuff, and that was cool. And so I was looking at this class again because it was offered the next year through the high school, and I'm like, how can we make this better? So my team and I actually wrote FTC curriculum into our high school. We wrote a grant for about $8,000 and got $8,000 of FTC parts to put into the high school. Wrote curriculum based on that project-based learning. We were graded on our engineering notebook. We were graded on our, basically the quality of our CAD drawings and manufacturing drawings. Graded on networking and competitions. There's actually an FTC team here, 4177, the Finger Titans, who also runs like a class. All the students are totally willing to talk to you about it if you're interested. So that would be one example of how to integrate first into your curriculum, is make it more of a project-based learning class. Kind of the second thing to touch on for teachers who might be looking of really simple ways to integrate project-based learning into classes or STEM experiments into classes. I actually work for the Program for Women in Science and Engineering at Iowa State, and we have it's like 86 different STEM activities ranging from biology all the way to forensic science to your traditional like gumdrop towers, where you build towers out of gumdrops and spaghetti noodles. And it's really good to get all ages of people involved in STEM. You talk through the engineering process, they get to build a thing, test the thing, compete against other people, and it takes like an hour. So all of those are available online. If you're interested in getting access to those, it's basically office supplies for all of it. And it's a really good way to just start that engineering design process in students through all ages. So yeah.
Thank you so much. Are there any other students? Oh, yeah. Oh.
That shows the different levels. It's Bloom's Taxonomy, BLOOM apostrophe S taxonomy. And you know what I'm talking about. And the bottom level, that's kindergarten, first, second grade. You need to be close up to the top for high school, and then the top two levels for college. And you start teaching with those ideas, and it tells you, create, think, not think, but create, analyze, and stuff like that.
Thank you so much. Is there any other? Yeah.
I'll give you the link. I don't know it off the top of my head, but if you find me afterwards, I'll give you the link. Is that?
Anybody else? Yep. Oh, Bill gets you too. All right, and please introduce yourself.
I'm Cassie, and I'm from Team 3637. We've been up here quite a few times, from New Jersey. And I'm actually in one of Mr. Brokaw's class, and I take a few other tech classes. I'm a senior in high school, so this is the first year I'm taking any tech classes to prepare for college. And one of the major things I found is in my Principles of Engineering class, we do a lot of CAD, and CAD is one of the most frustrating things you'll ever do. And the only way that you'll get used to that, especially going into college, is by doing it. Our teachers go, here, right now we're on a project that we have to create a claw that will pick up like a ball or something, and you have to design it, and you use different like syringes with like liquid in it, and it's like so frustrating, but you have to go through that process of being frustrated and finding the problems that you have and finding those solutions in order to be prepared for anything in the real world, because I've never had a class I feel like prepare me so much for college than those classes that I'm physically doing the work, finding my own mistakes and learning from them. Thanks.
Thank you. Yes. Can you introduce yourself as well?
Hi, I'm Aileen Gracie. I'm an engineer up in Ottawa, Canada. I'm mentoring an FRC team, but I'm actually up here as a mom because I saw my kids going through FLL, learning how to do drag and drop pictorial, and wondering how do I get them to jump from that to syntax. who's the one that's going to tell them that they have to put semicolons on the ends of dry written code lines? Am I going to kill it for them? And I wanted to say that Khan Academy, and that really, really helped, and it was pictorial, but they had to write lines of code and get their syntax right. And it was a beautiful step up from FLL to lines of code. And Scratch is another great way to get kids to the next level of coding without it being scary, and actually project-based where you're actually doing something. And then my son, who's 11, Arduino is a very great way to get kids to do project-based hands-on. People love to make LEDs, do what you want them to do. And that's C programming, very simple C. What I did for my son was I set up some libraries of functions for the RFID card. So if you wanted to do this, call this function. So I put the ugly code in a function so he could do, what do you call it, pseudocode coding in C and make the thing do what you want. So when kids see that they can make it do what they wanted it to do by writing some lines of code, it's really satisfying. So that's the way to get them to enjoy writing lines of code with semicolons and brackets, and if you can actually show that it gives you the power to make the LEDs do what you want.
Yeah, and you made a great point. There's a ton of resources on the internet, whether it be Codecademy or Khan Academy or Free Code Camp. There's a ton of websites that will help you on stuff like this. And can we first get a big round of applause for her?
And one more thing, teach kids that they can Google. And people have run into the coding problems that they're running into. Is it supposed to be a curly bracket or a square bracket? Ask Google, somebody's run into the problem before.
Thank you so much. And I just wanted to say, even though we're almost out of time, she made a great point about how you can find opportunities online, and also, at hackathons, like NHEX. But I think, a big takeaway that we want you to get out of this is that when you go home to New Jersey or Virginia or Ottawa, wherever you come from, try to make a difference, at your school and your community, because this is a growing movement, but clearly, as you guys know, we're not there yet in terms of getting every classroom situated on project-based learning. We've made NHEX because we thought computer science wasn't being taught the right way, and because there wasn't enough opportunities. And our own school actually, rejected us. Like, they didn't want to host it at our own school. So there's definitely going to be bumps along the path. But, we turned out all right, and I think you guys will turn out just fine too. So, please make an effort to, whether it be talking to administrators, starting clubs, starting, extracurricular groups. Just try your hardest to, catalyze the movement even further. And you guys are already doing a great job by being involved in robotics, because that's an excellent example of how you can apply STEM thinking into something practical. And, just a plug for those of you who are in Michigan, NHEX 3 is on May 19th. It is free. We have sponsors like Domino's, Microsoft. The Dean of the University of Michigan is attending. It's a great way to learn new things. We have workshops being taught from people at the University of Michigan, professionals. So yeah, if you guys are interested in that, maybe you can sign up at www.nhex.org/register. And for those of you who are from out of state or cannot make it, as a hackathon founder, and I'm sure my organizers would agree, is that maybe try and start a hackathon on your own, because we found that hackathons are a great way to energize the community and get everyone thinking about problems and ways we can solve them. So maybe if you guys are interested in that, we can give you some tips. Or if you guys have any questions or anything about what we've done here, our work, or if you want to know anything else, you guys can come and stop by after this and talk to us. But if not, you guys want to say anything?
As he said, if you have any questions, feel free to come up to us. We'll be holding a question session. And also contact us on our website, nx.org. We have our email on there. It's info@nhacks.org. If you have any questions, you want some resources, you want to know how to plan a hackathon, how to start a hack club or coding club at your high school, just let us know. We'd love to help you guys out. Thank you for coming, everyone.
Yeah, thank you guys so much. I think everyone deserves a huge round of applause. Thank you again to all the teachers and students who shared their feedback. And thank you to all of you for just being here and contributing to this workshop. So have a great day, have a great competition, and
Good luck, everyone.
Good luck to all teams.